Alright, last class we went out to the track and recorded the amount of time it took us to walk 50 meters, recording our time after every 5 meters. Today we're going to use that information and connect it with linear functions. So I'll go up to Spotlight and type in GeoGebra, which is an application that we'll use. So I'll open the application, make it big. From the perspectives, I'm going to choose Spreadsheet and Graphics. This gives me the option to input my data here. So I'll go back to the spreadsheet, scroll over and find Miss Durham, and highlight the two columns with the information for my distance and time. I'll copy that by doing Command C, go over to GeoGebra, highlight the box A1, and you do Command V to paste my data into the spreadsheet in GeoGebra. Now that I have this information, if I highlight those two columns, you can right-click and you'll have the option Create, and I want to create a list of points. Right now this only shows me 3 points, so I need to use my trackpad to zoom out until I see all of my points up through K. And to make the screen centered, I can hit Shift and then use my trackpad to center my graph to a point that I like it. Okay, so right there, and again on my x-axis, it's representing column A, which was my distance, 0 meters, 5 meters, 10 meters, 15. My y-axis is representing column B, which was the time recorded at each of those 5-meter intervals. Now if we highlight our data again, we can go up to this box. Right now it says one variable analysis. If we click the arrow, we can go down and choose 2 variable regression analysis. This shows me the data that I had entered, and I want to click Analyze. So right now it shows me my scatter plot again, and here it's showing me that my x-axis again is representing the column A, which is my distance. The y-axis is representing column B, which was my time. I'm going to choose a regression model linear, which makes sense because we're in the linear functions unit. So if I click that, it gives me an equation in red. Y equals 0.4956x plus 0.0091. What does that mean? Well, we'll get into that. But for right now, I want to record this information. So 0.4956x, I'll go back to our spreadsheet. And under my information is a spot to enter my equation. So y equals 0.4956x plus 0.0091. That was my equation for distance versus time. So again, if I go back, we were talking distance on the x-axis versus time on the y-axis. Now, just to mix it up a little bit, as we were talking independent and dependent variables last class, if I go up here to xy, this is going to switch my x and my y. So now I see that the x-axis is representing column B, so now my x-axis is my time, and my y-axis up here, it shows us, is representing column A, which we remember was distance. So we can also see that our equation has changed. So now my equation is y equals 2.0167x minus 0.0077. So I'll go and record that in my time versus distance. So 2.0167, 2.0167x plus minus 0.0077, minus 0.0077. So now I have an equation that represents my distance versus time. I have an equation that represents time versus distance, and then we'll be able to talk about what that means and what each part of those equations means related to linear functions.